Okay, go ahead.
Okay. Hello, everyone. We are Team CASTME. I'm Michael. This is Ramya. This is Manuel. And today we're going to be talking to you about the project that we did with Technicolor this semester. Okay, so just to give you an overview of our agenda for today, we're going to talk to you about why we're doing CASTME and what its purpose is. Then we're going to give you a demo on what CASTME is doing right now. Give you an overview of our system architecture, describe to you how our database is organized with all of our movie information and actors and directors. Give you a brief overview of our machine learning algorithms that we use in order to create this CASTME website. And then talk to you about feature enhancements that we would like to have in CASTME, and then give you an overview of our software engineering practices that we used throughout the semester. Okay, so CASTME is targeted towards casting directors and studios. So in studios are first in the initial phase of wanting to create a movie, they go through a process called green lighting. So with green lighting, they get a lot of different scripts from a variety of sources. And so as they're looking through these scripts, they then decide, okay, this is a good enough script. How about we fund this? So after they make that decision, then that's when they start looking for, okay, what actors would best fit this? What producer would be good for this? What director would, really bring this movie to the next level? And so that's where we want to get into in the process. So CASTME is basically allowing these studios to simulate a movie with the actors, directors, and even the genre, and everything that's being released in order to figure out if their movie will do well. And so just giving them a more informed casting, feedback, and then being able to see what happens when they do that. And so here's our system overview. The user is able to, again, input their actors, the directors, the genre, such as, if it's a comedy movie, if it's an action, or maybe it's a drama movie. And then they can do the release season, such as maybe making it a summer blockbuster, or maybe they want to release it in the fall. And then they can also choose the producer for the movie and even the studio, which we assume they would choose themselves. And then after they choose all of these inputs, then what they get back in feedback is success predictions. So it'll say, okay, for this star rating, it'll be, this number between, 1 and 10, so, 5.8 or, 9.0 out of 10. Or it also give you, what your, predicted box office revenue will be, like in millions of dollars. And then it'll also give you the box office run in a number of days. So it'll predict all of this information using the machine learning models that we worked on during the semester. And so in addition to the success predictions, it'll also give you recommendations on what actors you can, put in your movie in order to possibly make it even more successful. And so that's what overall CASTME does. And so now we'll give you a demo of our working product. Okay, and so here's the starting page of CASTME, a pretty simple design for our user interface, And you start off, it's loading our actors, but actually let's make sure the database is running. Sorry about that. Oh. That's weird. Oh, okay. Sorry about that. Okay, so we have to make sure our database is running. And so when you start off, first thing you go to is the actors. We have over 1,500 actors you can choose from and search in our database. And so you can go with any type of movie. You can go with like a comedy, action, drama, whatever you think you want to try out with the supposed movie. So what we'll do first is maybe try to do a comedy movie with somebody like Vince Vaughn, or maybe Owen Wilson, and we'll just see, And so when you search up these actors, you can, just to get a better idea of like if they would fit your movie well, you can click on info and see the movies that they've been featured in. And so as you can see, he's been in movies such as Shanghai Nights with Jackie Chan, that's a pretty good comedy movie, or even Meet the Parents, it's definitely a good comedy movie. Wedding Crashers, everybody likes that one. So yeah, let's throw in Owen Wilson because we think he'll be a good addition to our movie. And then we can also add in more actors and Again, let's do another search for somebody like Mila Kunis, who's also, definitely a comedy person. She's in That 70s Show and all these other things. So, and then the movie she's been in, Forgetting Sarah Marshall. So let's add her in there. Okay. And as you can see at the top, it's saying that you still need more inputs. So you have to input, all different, factors before you can get back, a good prediction on how your movie will do. And so now we're going to directors, and we choose somebody like Kevin Smith. I know he's done some comedy movies, and again you can see info what he's done, Clerks and Jersey Girl. So yeah, we'll add him in there as our director. Then we'll go to our producer, and of course we got somebody like Adam Sandler. That's definitely somebody who would probably fit our comedy movie description. And then we can go with Veronica's already choosing something like Universal. So Universal, they always make big budget films, so how about we just, put them in there. And then the season, we can choose something such as the summer, that's a good time to, show different movies. And then the genre, as we've already said, we're gonna make a comedy movie, so let's do that. And now you can see we get our predictions. So right now it's saying that the box office run will be about 54 days in the box office. It should make between 1 to 20 million. That's what the predicted revenue is right now. And then it's predicting a star rating of 5.8 out of 10 on IMDb. So that just gives you a pretty much good overview of how you think your movie will perform. And so in addition to this, we could also, click on an actor and see what type of recommendations they have as far as like who would be a good replacement for him as far as making it better. And so you'll see people like Jack Black, he's a comedy person, and you'll see somebody like Cedric the Entertainer. He's definitely in a lot of comedy. So we can throw in Cedric the Entertainer and we replace him. And right now you can see it increased to 61 days, so that extended the box office run for about a week, which is pretty good as far as a movie goes. And then the IMDb rating didn't increase by that much, it only increased by 0.1, but that's just something that we're still, oh yeah, question.
So how do you make this prediction without even the script of the movie?
Yeah, that's another thing.
Right?
Yeah, that's another thing.
Doesn't that add a lot into it?
It's definitely important.
It does, but like say, I don't know, maybe you put a comedy movie star in a horror movie, like something which you shouldn't be doing, so at least this can capture like typecasts. Like if somebody, like who are the good people for comedy, or which are the good pairs that people might want to see together. It won't, obviously the script makes a lot of difference over these predictions, but at least it could capture like some of the typecasts and like pairings, maybe like what has worked in the past.
And I guess if a certain actor, every movie they're in is a success, then you probably assume that they don't pick a bad script. Is that what you do?
Yeah, I guess the thing is we talked to Technicolor.
Like, what was that one? Olympus has fallen or something. Like it had a good star cast, but then it didn't do really well. Like the IMDb rating was just around 6 or something. It was mediocre. But I guess if you put such a huge star cast into this system, it would probably say that this movie is going to do awesomely well. So obviously the script matters. So maybe we could in the future like add in more tags to like accommodate for like some parts of the storyline, like twist in the end. You could have more tags, and then you could like train your model with those things to like get better predictions.
So it might be fun. It might be fun to take one that a movie that's being casted right now, and how actors are thrown off of it and actors are added back in, like the 50 Shades of Grey.
Oh yeah.
It's kind of interesting. They'll say, oh, okay, this actor was in here, and then, oh, they're out. And then they plugged in a new one. And it'd be kind of interesting to see, what the ratings would be that you would calculate.
Yeah. And that's kind of the whole point that, Technicolor is really big on this project. And even when we did our project, or even when we did our presentation on Tuesday, they kind of actually also talked about the whole script thing and actually using like the synopsis from something such as IMDb. And using that as a...
So yeah, so IMDb does have a synopsis on every movie, so
right.
we could also incorporate like major tags or highlights from the synopsis into the prediction model.
Oh, you like the keywords out of
Yeah.
the
So
synopsis?
So then
Yeah.
maybe you could
Yeah.
have a better model and better
So
predictions.
there's definitely a lot of
So
future
that
work
was
to
a,
do there.
a part of the future plan.
And then, and I know you have predictions here,
Yes.
but how about if you put in actual data, how accurate is it?
Oh,
Like if you know a particular movie,
Yeah, like it is.
or are
able-
you saying it already trained on it, so it would know it already?
No, if you like test it with an action movie from IMDb, it's like it is able to predict mediocre movies well, but it's because most of the movies in IMDb are concentrated around 5.9 to 6.7, like so on. There are very few which have like 9, and there are few which have like lesser. So the model is not like so it mostly can get the mediocre movies predictions well, but not. It doesn't like capture all the. It, for example, is not very sensitive to change in genre right now. Like if I cast Jim Carrey in a action movie, might not understand that it's not going to work well, because it sees that whenever Jim Carrey is there in a movie, it is done well, because he usually chooses comedy movies. So yeah, so there are like, you have to make it somehow, make the model better. So that's about our demo.
Sounds like really fun. Did you get to watch a lot of movies too?
But
It
yeah,
was good
we
to
were
know.
browsing on IMDb a lot.
Okay, and so here just to give you a little system architecture of how everything's set up. So as you can see, we have the front end that we showed you, just built with the basic, web essentials of HTML, JavaScript, CSS. And so in our front end, we're communicating with our back end just through JSON messages. And our back end is running on a framework called Java Play. And so Java Play, communicates with our front end and our database and our machine learning models. And so for our database that we're using MongoDB, which has, everything as far as like all the actors and what movies they've been in, and the directors who've done work with whatever producers. It just has everything in there. And so our machine learning models, which are built on MATLAB, train on that data inside the MongoDB. And so when the Java Play framework gets the information from the front end, so as far as like the selections for our actors and producers, then it can use that recommendation engine, the prediction engine, to feed back the front end, what the
So why MATLAB?
MATLAB. Well, I know that was the decision that Rania went with. She was, yeah.
They gave us the choice to choose like whatever we are comfortable with. They didn't really have a choice in that. So initially we decided to use Apache Mohawk because it was in Java and all of us are really comfortable with Java. But then, so we just went ahead, but later we realized that it did not have certain algorithms which they had in mind and which we would be using. So then we had to scrap that, and then we were considering either R or MATLAB. But they have licenses to MATLAB and they have used MATLAB before. And we also have done a little bit of work on MATLAB, so we just picked that out of the two. So like we did consider other stuff, but no, it didn't work well. So MATLAB, then they also had some experience using MATLAB. So we thought we would get guidance if we needed. That's why.
Okay, so now I am going to talk about the data normalization part of our project. So as you can see from the demo, in order to show all the performance information directors, we had to deal with a big data set. But in order to get that data set, we have to do a lot of cleaning. In the very beginning of the project, Technicolor gave us information about movies. They gave us information about performers, directors, producers, studios, movie information. All of this was very easy to manipulate because they had IDs which relate the movies with the different performers. However, they also give us box office information, like the box office run information and the box office revenue. But in that case, this was coming from a different source. So it was not very easy to relate movies and box office. And also, in the case of box office, we had some trouble because This information came in a entry. Yeah, the information that we got from box office revenue were entries per day, per movie. So for example, for the movie Prisoners, we have 3 entries here for 3 different days. So in order to choose the information that we want, we have to choose the latest date, which has the latest information about box office revenue, which is this number, and the latest number for box office run, which is this number. So using that information from the last entry for each movie, we are able to get information relevant to us, which is box office run and box office revenue. Then, in order to be able to link together the box office information together with the movie information that we had already, we thought that we could use just the movie names. However, in the process, we realized that there are movies which have the same name. For example, we found this case of Titanic. Titanic has several versions. So taking the name in consideration is not enough. We also used the release date information so that we can make better matches. And once we were able to merge the information, yes,
So what happens when a movie is re-released?
re-released. So it's considered like a different movie.
It would
Well,
still
this
have a
one-
different release date.
It also has, it has a different release dates, and it also has different performers usually, so it's like
Well, it's
another
just-
movie.
Same movie, it's just released sometime. Disney does this.
So an example could be like
Oh,
Star Wars Episode 4 was released in 1977 and then again in 1990.
I see.
Oh, so it's the same movie, it's exactly the same
It's the
movie?
same movie that they made a couple of changes to and then
Yeah.
re-released the whole
Oh,
movie.
okay.
as a
Right,
new
right,
edition.
right.
So I think we would just pick the latest one.
But if if you look at IMDb, they actually have 2 separate
Mm-hmm.
entries. So I'm guessing you guys would treat them as 2 separate entries.
Yeah.
It would be
Yeah.
separate entries.
yeah, I guess you could still do it by release date.
Yeah, so then
Yeah.
it would be considered 2 separate movies.
Yeah.
Mhm.
But I guess we don't have data ranging so far back.
Uh,
It's just like
Yeah, the box office revenue is not so old, yeah, it's from 1993, yeah. So once we are able to merge the data together, we also had to filter out those which didn't have IMDb information, because that's information that we are going to use for the predictions engine. So once we filter all those movies out, we are able to build this binarized feature matrix, which is basically a binary matrix which has in the columns it has movie features. For example, seasons. It could be fall, winter, summer. It has genres, producers, performers, etc. And in the rows, it has movie titles. So, for example, in the case of the movie Inglourious Basterds, this is a movie that was released during the fall season. So it has a value of 1 for that entry, and it's a drama movie, so it has a value of 1, 2, and Quentin Tarantino directed that movie, so it has a value of 1, and so on. Similarly, for the case of the curious case of Benjamin Button, it was released during winter, so it has a value of 1 for that entry, and for drama, it's a drama movie, so it has a value of 1, and so on. So after creating this binarized feature matrix, Remy started to work with it for the predictions engine, and she will explain about it further.
Yeah, so the data which we received was it had around 1893 movie samples, and it had around 60,000 features initially, like putting together all the top actors, directors, producers, studios, genres, and seasons. So as this matrix was too huge to work with, we first decided to reduce it by only selecting those features which appeared in at least 5 movies. So after doing that reduction, we got a matrix of 1893 movie samples and around 2,400 features. And also, as Manuel said, we filtered out those movies which did not have an IMDb rating or a box office revenue or run. So then the final matrices that we obtained are listed on the slide. So the first step was prediction of star rating. So we decided to use linear regression to predict the star rating. but the matrix that we currently have at 2400 features was still too sparse for any linear regression output to be good. So we had to reduce it further. So we decided to do dimensionality reduction, and we used a technique called singular value decomposition. MATLAB offers several options for linear regression. It has different models. There's a linear model, there's pure quadratic, there's interactions depending upon the associations between the predictor variables, which in these case are your features. So to decide the optimum value for the SPV rank, that is the number of columns, number of features that you want to reduce your original matrix to, and to decide which of these models fit best, I tried out various permutation combinations. Some of them did not work at all for this data set, like the interactions model didn't work at all, but linear and pure quadratic seemed to work. And we can see that here for a rank of 90, we get the lowest root mean square error. What is listed in this table is the root mean square error. So you can consider there would be an offset of around plus or minus 1 on the star rating. So this is the value we decided to go with. So our matrix now has reduced from around 2400 features to 90 features. So that was the first step. So then to see if we could get better results, we tried regularized regression. That simply places constraints on the weights or the beta coefficients which are obtained. So I tried different techniques. I tried lasso and ridge regression with different values of penalization factor. And we found that for ridge factor k equal to 100, the RMSE error is lower than the one obtained in the previous step, which is linear regression. So this is what we are currently using in the website. We also tried doing the same thing, that is regularized regression, without any dimensionality reduction. That is on the original matrix of 2400 features, but that didn't work very well. So in that case, the error was around 2.2, which is pretty high on a scale of 1 to 10. So we scrapped that, and we continued with ridge regression with a ridge factor of 100. So now that you have your weights assigned to each of the factors, how do the predictions work? So we imported these values into our Java Play backend. Now when the user is selecting a movie at the front end, we build a matrix. This matrix is of the original size. In fact, it's an array of 1 into 2, 4, 3, 1. So we build the matrix like Manuel had built the binarized feature matrix in the first place. But then this matrix, we have to reduce it to get any predictions from it, because we have trained our model with a reduced matrix. So we multiply this matrix X with B. That is one of the outputs obtained from dimensionality reduction, that's from SPD. And then after multiplying that, we scale it down by the eigenvalue, which again is obtained from SPD. So then you get your reduced matrix of 1 into 90, that is M. So that you can just multiply by your weights to get your output of prediction. So each time a movie is, the user selects a movie, the original matrix is created, which is then reduced and then multiplied by the weights to obtain your prediction. So these are some checks that we performed. We wanted to see if the mapping from the sparse space to the latent space is correct, because we are training the model on U, and then we are trying to recreate it by multiplying X into V and performing the whole computation. So we performed this check on several movies and found that it mapped exactly. So what we were doing was correct. So that checked out. So that was about star rating prediction. Now for predicting revenue, the revenue value values are in millions, ranging from less than 1 million to around 600. So this is a histogram. On the y-axis you have the number of movies. So here we have around 1800 movie samples, and this is the box office revenue in millions. So again, we tried out the same things first. I tried dimensionality reduction and then linear regression, different models of linear regression. But in this case, the root mean square error was on an average around 50, which was quite high. One thing to note is that here the range is much more. It ranges from say 0.5 to around 600. So error of 50 is actually better than an error of 1 from 1 to 10. But if you consider the 50 as 50 millions, if you're off by 50 millions, then that's a lot. So we did not go ahead with this linear regression. Again, I tried regularized regression with different with ridge and lasso and different values of ridge factors, but same thing, the results were similar. It gave an error of 50, which was too high. So next thing we tried out was classification. We decided to classify the revenue into like 6 classes. So we made different ranges. So these are the 6 classes, like less than 1 million to around greater than 200 million. And we tried out multinomial ordinal logistic regression. And here the misclassification rate was found to be 61%. But that alone doesn't give the complete picture. Like if you look at the matrix below, it is the confusion matrix, and the features are the target class, which is the correct output, and the rows are the predicted output. And so the values on the diagonals are what the system was able to predict correctly. But you can see that whenever the predictions are wrong, it is mostly misclassified into neighboring classes. So in the sense, this is bound to happen because it's a continuous range of variables. So if in case you were just to classify your movie into a blockbuster and a non-blockbuster, by saying that blockbuster would be about 100 million and the rest of the classes would be non-blockbusters, then the same system would perform better. Then in that case, it would be able to predict like pretty much accurately if it was a blockbuster or non-blockbuster. So while not great, the results were certainly encouraging. So we also tried classification with some other algorithms. I tried neural network classification, and again similar results were obtained. The misclassification rate was around 62%, with misclassification mostly being into neighboring classes. So the next step was to predict the box office run. This again is the histogram of the box office run in days. It ranges from around like 30, as low as 30 days to like 700. Like there are certain movies like Titanic which ran for like more than a year, but very few of them. So here again we tried out the same steps. We started with dimensionality reduction and linear regression. But as in the case of revenue, here again the error value was like too high. It was around 50. But we didn't really try out different techniques. This is what we're currently using in the website, but there is obviously like a lot of scope for improvement. Maybe you could do like a classification algorithm with run 2, or like try out other algorithms for prediction, so as to improve, like get down this error rate. Yeah, so I did try out regularized regression, but even that gave like similar results of around 50, error of around 50. So there is like a lot of scope for enhancements. There are several other algorithms which they suggested we could try out. So yeah, I guess the future development teams. So we have this entire pipeline set up now. So all the other development teams, the future development teams, will just have to like try out different algorithms, get the beta coefficients or weights, and just plug it into your backend so your whole website works. So it's very easy for them to like try out new things now that we have this whole setup established. So Manuel will talk about recommendations.
So our goal for the recommendations engine was to be able to show the top 5 best performers in the website. So when you choose an actor and you want to have an alternative, I want to show you some 5 recommendations. So what we did is we used our predictions engine in order to get which are the top 5 best performers replacements for an actor. But well, what we had to do was to run this predictions algorithm through all our actors. But we have 1,907 actors. So as you can see, the search space is really big. It will take a lot of time in order to find which are the top 5 best performers. And this is very inefficient. So what we did is we came with a heuristic alternative approach. So we used clustering as a way to reduce our search space. We decided to use 250 clusters. In order to use clustering, we used the reduced matrix that was previously used during the predictions development. We had matrices with sizes of 100, 80, 50, and 10, and 10. So here I am just showing 2 of those results. Here, this is a result for the matrix which has a rank of 100. This is a graph which is showing the cluster number versus the number of actors in each cluster. So as you can see here, in the first cluster, there are 120 actors, and then as you go on, there are also clusters which have only one actor. So this is not very useful for our objective because we want to reduce our search space, and if it happens that the actor that you are looking at replacement for is in the first cluster, you will have to run the predictions algorithm 120 times in order to find which are the top 5 best replacements. So this is not very good for our purposes. In this graph, I am showing the result after I clustered using a matrix with a rank of 10. In this case, the groups are better. Is more uniform. You can see that in the first cluster it has 25 performers, while in the last one, in the last cluster, it has around 3. So this is in compared to the first graph, this is more uniform. So we used these results. These are some of the clusters that we found that are very interesting. For example, in this cluster we found these actors: Keanu Reeves, Chris Evans, Halle Berry, Hugh Jackman, and Carla Gugino. As you can see, all these actors have acted in superhero movies, so this cluster makes a lot of sense. Another cluster example that we found interesting is this one. This is the type of rom-com sweethearts performer movies. We have Ashton Kutcher, we have Hugh Grant, and Sarah Jessica Parker. Some more examples are these ones. In this one, you can find Owen Wilson, Stephen Root, Ben Stiller, Jack Black, Jennifer Coolidge, Cedric Turner, and Blake Clark. This is a comedy type cluster. Also, one interesting thing that I found out about this cluster is that there are many actors in this cluster that have also lent their voices to animated movies. For example, Jack Black lent his voice to Kung Fu Panda. Ben Stiller lent his voice to Madagascar. I believe Cedric the Entertainer also lent his voice to Ice Age. So that's very interesting. And another cluster that we found is this one, in which we find Jennifer Aniston, Jason Biggs, and Jennifer Lopez.
Is that one for drama?
So
Yeah.
yeah, you could say that this is like a comedy drama
Maybe
kind of.
Chick flicks drama.
Jason Biggs, Jennifer Aniston.
So I am going to talk about now some future enhancements that we have in our mind. So for the predictions part, Ramil has already said we would like to try other algorithms in order to improve our predictions. For the recommendations part, we would like to try other techniques in order to reduce the search space. Currently we are using clustering. For it, we also want to, so now we are only doing recommendations for performers, but it will be also nice to have recommendations for the other features such as release season, directors, producers, production studios. And one important thing that we are not really taking in consideration is the role type. For example, if you want to create a superhero movie, there is always a hero and a villain. But we are not taking that information in consideration. We are also not taking in consideration the genre of the actor. Before, when I showed you some cluster examples, we found clusters which had females and male actors in the same cluster, but that doesn't really make sense to have. And also the age is also very important information that we should take in consideration. In regards, yes.
Okay. So where it says hero, villain, genre, age, you mean gender
Yeah,
or
I
genre?
guess that's a
Oh, sorry, yes, that's a mistype.
Gender,
It's okay.
okay. Now I feel better.
In the case of the website user interface, we would like to have integration with Facebook, it would be interesting to have a Facebook app, and also it would be cool to maybe be able to share the results that you have for a movie with your friends, so that they can give you some recommendations. Also, we would like to implement users accounts, so that once you log in, you are able to save movie information that you have selected, and then you could recover that later. And also, we would like to make the user interface more responsive, so that it can work in different screen sizes. We believe that our application will probably be used by directors, and we think that probably they might be using a tablet, so it would be cool if our website also works well with a tablet and different devices. Now, changing a little bit our focus, we are going to talk about our software engineering practices. So our team, we are 3 people, and we have different team roles. So Michael focused mainly on the user interface. Ramia focused mainly on the predictions part of our website. And me, Manuel, I focused on the back end. I focused on the MongoDB, the database, and also on the recommendations engine of our website. Now I'm going to talk about some of the agile, about the agile methodology that we chose. So we picked a customized version of Scrum and XP. We did a hybrid. We used some of the practices that made sense for us, given that we are a short team and it's a short project. So we had an informative workspace. We used to go to Technicolor every week. So there we had our own office. We had a board. We were able to draw some things on the board whenever it was needed. We used story cards in order to track our progress. Because we work in Technicolor, but also on campus and at home, we couldn't have physical story cards, but what we did, we used Trello so that we could check the story cards wherever we want, wherever we are. We also did daily stand-up meetings. In the very beginning of our project, we only had two stand-up meetings. That was when we went to Technicolor, we had those stand-up meetings, but then we realized that it was not enough. We were not having the desired progress. So we decided to increase the frequency of these stand-up meetings. So instead of just having them whenever we went to Technicolor, we also had them virtually. We had them 4 times a week. And this proved to be really a really good change. Our team productivity increased a lot. Another thing that we had is we had weekly meetings with our client. Whenever we went to their office, we chat with them, we show our progress, and then they were able to give us feedback, and we would act accordingly. We had 3 iterations. In the first iteration, we mainly focused on defining the technologies, the architecture, and the scope. And then in the second and third iterations, we were mainly developing the website. And we also had reflections after every iteration. That's when we, for example, in the first iteration, in the first reflection, we decided that we would have more frequent stand-up meetings instead of just 2. So this was also very, very useful for us. So now Ramia is going to continue talking about our software engineering practices.
That's just our workspace at Technicolor. We had a room to ourselves, as Manuel mentioned, and we could use all their resources. So it was a pretty nice environment to work. And we had them drop by like every Tuesdays for discussions whenever we were there.
So do you recommend future practicum teams to work there?
Yeah.
Yeah, definitely, at least
Did we work
once.
at Technicolor or like go over to the client?
At Technicolor.
Yeah, it was really nice.
It was really
working
cool
with them.
to work with them.
So yeah, so the next one is
Their
about
coffee's
like
better
client.
than our coffee too.
Okay, I'm going.
So the clients, they were pretty flexible with regard to timelines, and they were very approachable. Like even when we needed help during the week, they would like do a Google Hangout with us, or like call and just like discuss and solve our issues so that we weren't stuck. And they pretty much gave us freedom to like choose whatever technologies we wanted. They didn't say that this is how we want things done. They were very open to suggestions. Like we did the whole UI ourselves, and they just had like minor modifications. They pretty much let us like handle things on our own and just like gave guidance when we needed it. So some of the issues we faced were that we were working with several new technologies. Like none of us had any background in machine learning. And also, as I said, the client gave us freedom to choose whatever technologies we wanted and that whatever tools we wanted to use. And while that was a good thing, it also had its disadvantages, because at that time we didn't know that what would work well and what wouldn't. So we didn't have any baseline for selecting the tools. Like I said, initially we just went with Apache Mohawk for machine learning because we just knew Java and we thought, okay, we can figure this out maybe. We didn't do our research well, like we didn't see if it had all the algorithms we needed. So we just like started off by choosing something. So we learned our lessons. So so when we decided to change over from Mohawk, we researched, we looked into MATLAB and R, and like we actually said, yeah.
Were you able to ask some of the other machine learning professors here for some advice, or some of the grad students?
Regarding tool selection or regarding the algorithms themselves?
For regarding the machine learning tools and the algorithms.
At the beginning, we didn't really think. We thought like all of the libraries would be equivalent, and we can just like choose whichever like we seem comfortable with. But it doesn't look like that. Like some of them don't have like features for all algorithms. So we should have done that, probably consulted someone. We did ask our advisors at Technicolor, but they were like, oh, you're free to choose. You can look into whatever is comfortable. We don't mind anything. So it's like, okay. So we should have probably done a bit more research, so then that little bit of rework would have been used. But nevertheless, it was okay. Like after we switched to MATLAB, everything went fine. So another issue was the lack of organized data sets. Manual took a lot of time organizing and linking the data sets. And also, they gave us an option to choose between SQL and NoSQL. They had all their data in MongoDB, but they were like, if you want, you can choose SQL. And they didn't really tell us like which would actually be better. They were like, it depends what you want to use. So we didn't know what would work well for this kind of data. We didn't even have the data at that time. So we just thought, okay, MongoDB, NoSQL would be cool to learn maybe. So we should probably try that. So at least we get to learn something new. But it did not really turn out to be the best choice given the nature of the data. A SQL database would have been better, it would have been more organized. But we managed, and we did learn MongoDB, so I guess whatever we had in mind was like accomplished. So if the data sets were like more organized and linked, so we could have started our machine learning module like much earlier, and probably would have gotten much more done. Like we could have tried out many more algorithms and gotten probably more accurate predictions. So those are our project milestones. As Manuel already mentioned, we had like 3 iterations of about a month each. So by after a month, like on September 27th, we had targeted that we would need to, like, we wanted to have our data sets organized by then, and also have defined a system architecture, which we were able to achieve. We defined the architecture in detail. We discussed it with the client. They approved it. The second one was October 29th. We wanted to complete phase 1, like we wanted to complete the whole predictions module. So when I say we did not achieve it, it doesn't mean we were totally off track. We were predicting star ratings at that point, but we hadn't yet touched the box office revenue and run. Even with the ratings, we first started out with just a few features. We didn't want to like jump into it with all the features, so we just considered the actors, the genres, and the seasons, because we wanted to see how it would do, and we wanted to just establish the whole flow. But also we had thought that we would first complete the predictions and then begin the recommendations. But it turned out that, and I was supposed to do both of them, but then Manuel got free, and then Mike didn't need too much help with the UI, so he was flexible, and he was like, I can take on the predictions because I'm not really doing anything with the database anymore. So then he simultaneously started working on the recommendations. So then for our final target, we were able to complete what we had planned, like we finished all the 3 predictions, and we were able to do the recommendations for actors as well.
Wait, so I think what you're saying is you didn't achieve the first phase at all, or
No.
or
We wanted to finish
you achieved
suc-
it late?
We didn't achieve it completely. Like by finishing success predictions, there are 3 metrics. Like we have rating, revenue, and box office run. We were only able to predict rating at that time. So we didn't like do all of
But
them.
how about now?
Yeah, we completed
So
success
now you
predictions,
saw,
yeah.
like we did all 3 of
Right.
them late run. So we achieved it late.
Okay,
Like we caught up in like the 3rd iteration.
okay.
Because he simultaneously started working on recommendations, so I was free to complete my work on predictions. So then I finished that, he also finished that, so it just
Okay, good.
got together. So that's all we have.
Do you have any questions?
Patrick?
I have questions. I have 5. These are sort of questions, sort of things that you might want to mention as future work if the answers are no. First question I had is when you're doing your training and your prediction of revenue, does your computation adjust for inflation?
Inflation?
So if a movie in 1985 made $10 million and I made the same exact movie today, it would hopefully make $100 million, right?
Yeah.
I guess our data doesn't go back to.
No, we are not really.
Or is it
taking
mostly just
inflation.
No,
current data?
the data is more current, right?
Oh yeah, it's not so old, like from 1993.
It's from 1993.
Yeah, the box office revenue is from 1993.
So that is
Okay.
still there is.
But-
But we are not,
You're not
another
doing
thing
that.
that they wanted us to take into account was the budget.
Right.
So like they did say that, but they were like, these are some of the first things that you can try out and just see how
Okay.
it goes.
Sure.
So yeah, those were obviously things that would be in focus.
Yeah. So one of the questions that I had when you were giving your demo, suppose I choose a really stupid combination of people.
Mm-hmm.
Suppose I pair Brad Pitt and Jack Black.
Mm-hmm.
Would I just have to go through the entire process of figuring out why my recommendation came out bad? Or is there a way that your system could pop up something and say, hey, wait a minute, these people don't belong together? Or do you really need the full selection and the full analysis to figure out just the dollar amount is low?
I don't think it yet gets the associations between these features well.
Okay.
Like it's just like if the data is such that if Brad Pitt, whatever movies Brad Pitt has appeared in are mostly successful movies, so it doesn't know that combinations. That's what some of the
Okay.
things we mentioned. We want to capture
Yeah.
those associations. So even if you put stupid people together, it probably gives a mediocre rating, but it doesn't give a very low rating. It
Right.
wouldn't say that this won't work, and if you give like 3 or something,
Sure.
it doesn't do that. It just gives a 5 at the most.
Okay.
So yeah, that is something we need to work on.
Okay. Do you want me to keep asking questions? Or?
Sure.
Okay. So I had a question about you showed sort of the misclassification matrix, and you said it tended to be sort of minor misclassifications,
Like
right? Just off by off on the
yeah,
diagonal, but
one
not by very
class,
much.
Yeah, but it's because the classes are say from 1 to 20 instead of 20 if you do 21 we do
Yeah.
in this class.
Sure.
So if it's 20 to 21, it's not too much of a difference, but say 1, like the lower end and the higher end is a
Mhm.
difference, quite a
Yeah.
bit of difference.
So I think a really good way of capturing that in a metric is instead of just saying the misclassification rate is X,
Mm-hmm.
you can say the misclassification rate is X and the average error in dollars
Okay.
is Y.
Yeah.
So then if your misclassifications are there but they're small, it tells you something different from 50% error and $5 million of error versus 50% error and $5 billion of error are completely different.
But the output of the algorithm was such that it only gave probabilities of them belonging to various classes.
Yeah, exactly.
Yeah.
So probabilities of classes
Mhm.
gives you exactly error.
Okay. True.
You could just say $1 to $20 million, I'll call that $10 million if the error is, if I make that mistake 10% of the time,
Mhm.
that's $1 million error,
Yeah.
right?
Yes.
So that's a way that you could actually capture
Mm.
the dollar amount error in addition to
Yeah.
the misclassification. I'm not saying what you did is bad, I'm just saying this is something extra that
Yeah.
could be even better. The other comment that I had is when you're doing your analysis between revenue and run, those seem to be not independent in my mind. So if a movie makes a lot of money, it's probably because it is in the box office for a long time, right? So that might be something that the future team who picks up this project and works on it could try and look at the dependencies between those two things and try and come up with sort of a joint joint classifier for that. That was more just a comment. I wasn't expecting you to actually. So yeah, those are just some things that you could possibly include as things for the next team
Yeah.
to work on.
To work on, sure.
That's all.
Ed?
So, knowing what you know now, if you were to do this project again, what would you do different?
Regarding at least the tool selection.
I don't know, anything.
Yeah, so we would not choose MongoDB.
Yeah, we probably
would
would use
choose
just
a
MySQL,
database
MySQL,
because
yeah.
it took so much time getting, like even till the end, the data set, he would give me different data sets like up to last week, and then I had to run the whole pipeline again, but I had my scripts ready. But we were having several problems with the data itself, so then it was like run through all these algorithms again. But because the pipeline was ready, it didn't take much time, but still that was like some amount of rework. So I guess if you select the correct kind of
Tool, yeah, you have
it
less of a
would, it
headache.
would have been better. But some things which worked really well was like the division of work. We thought like even at Technicolor, they were asking like what are their problems interfacing, because he was just working on the UI, he didn't know about the other two things, and Manuel was the only one who was working with the database primarily, and we didn't know like too much about MongoDB. But there were never any problems at any stage, and the division worked really well. Like when I wasn't ready with the machine learning module, he was just like simulating random values to check the UI, and when I was ready, we just integrated it. So that worked fine. What else would we change? I guess
Maybe about the agile
stand-up
practices.
meetings. Yeah,
we would
stand-up
have.
meetings. We were just doing them twice a week, and then we didn't really know what other people were working on in between those meetings. So we used to go to Technicolor on Tuesdays and Fridays initially. So that's when we'd had our meetings, but then we changed that later on. So I guess we would adopt that audio and do daily stand-up meeting. That was really useful.
In addition to all that stuff, I know that we met some people towards the end who were also like working with some of the machine learning stuff, like not Udi and Smithy, but like some of the other
others in the
employees there. So it probably would have been like pretty good to like get in touch with them since they like touch the same data and stuff.
Mhm.
So I know Rami and that one girl
Yeah,
working with
like
each
towards
other.
the end we found other
Made it
people
good.
who were working with the same data, so they were able to provide some insights. Maybe we could have like taken help from elsewhere, like earlier, instead of trying to figure out everything on our own.
Yeah.
Yeah, good job.
Right. Thank you.
Give him a round of applause.